Every enterprise is racing to build AI agents, but here's the problem. Most teams jump straight into coding without understanding the architecture patterns that determine whether their agent will actually work in production. The result? Fragile agents that loop forever, burn through tokens, and hallucinate their way to failure. Welcome to a 5-part series where we break down every major agentic architecture pattern, from simple single agent loops to complex multi-agent swarms, production guardrails, and framework selection. By the end, you'll know exactly which pattern to pick for your use case. Before we dive into specific patterns, let's set the stage. An agentic architecture is the structural pattern that defines how one or more LLMs interact with tools, data, other agents, and humans to accomplish tasks autonomously. Think of it like the blueprint for how your AI system thinks, acts, and recovers from mistakes. There are 5 key dimensions that differentiate these architectures. Autonomy versus controllability. How much freedom does the agent have? Latency versus thoroughness. Fast answers or deep research. Cost versus quality. How many tokens are you willing to burn? Single model simplicity versus multi-agent specialization, and deterministic workflows versus free-form reasoning. In this episode, we start with the simplest category, single agent architectures. One LLM, one loop, one mission. The most well-known agentic pattern is ReAct, reason plus act. The model explicitly writes out its reasoning as a thought step, then chooses an action like calling a database or searching the web, then observes the result and loops. This makes the agent's decision process transparent and debuggable. Let's walk through a concrete example. The agent receives, find the account details for customer 12345. It thinks, I need to query the database. It acts by calling the database tool. It observes the result, Acme Corp, enterprise plan. Then it thinks, I have what I need, let me format the response, and it exits the loop. The beauty of ReAct is transparency. Every decision is logged, but the risk, infinite loops. The model can get stuck in cycles or worse, hallucinate tool outputs instead of actually calling tools. Production implementations need 3 safeguards: max step limits to kill runaway loops, output validators to verify tool calls actually happened, and fallback handlers for graceful failure. Next is the code act pattern, and this one is a game changer. Instead of structured tool calls, the agent writes and executes actual code to accomplish tasks. Tools like Claude Code and OpenAI's code interpreter use this approach. Why is this so powerful? Because code is a universal action space. With traditional tool use, the agent is limited to predefined tools, a search tool, a database tool, a calculator. With Code Act, the agent can compose arbitrary logic. Need to parse a CSV, filter rows, compute aggregates, and generate a chart? The agent just writes a Python script that does all of that in one shot. The trade-off is safety. You're letting an AI execute arbitrary code, which means you need sandboxed environments, resource limits, and careful output validation. But for tasks like data analysis, code migration, and infrastructure automation, Code Act is incredibly effective. The simplest single agent pattern is the tool use loop. No explicit chain of thought. The model receives a task, calls tools as needed, and returns a result. This is what most API-based tool calling implementations look like today, including the Anthropic Messages API, OpenAI's function calling, and Amazon Bedrock's tool use. It's simpler, cheaper on tokens since there's no verbose reasoning, and faster since you skip the thought steps. But you lose transparency. When something goes wrong, you can't see why the agent made its decisions because it never articulated them. It's a black box. Let's put all 3 side by side. ReAct gives you the best transparency and debuggability. It's your go-to for complex reasoning tasks where you need to understand what happened. Code Act gives you the most powerful action space. Reach for it when the task involves data processing, file manipulation, or anything code can solve. And the tool use loop is your efficient workhorse. Great for straightforward tasks where you just need tools called reliably. And here's the thing. In production, these aren't mutually exclusive. A ReAct agent might invoke Code Act for a specific step. A tool use loop might escalate to ReAct when it hits a complex subproblem. The best architectures are composable. That's part one, the foundation. You now understand the three core single agent patterns: ReAct for transparent reasoning, CodeAct for powerful code execution, and the tool use loop for efficient simplicity. But a single agent can only get you so far. What happens when you need multiple specialists working together? In part 2, we go multi-agent, orchestrator worker systems, hierarchical teams, adversarial debate, and swarm architectures. This is where things get really interesting. Subscribe so you don't miss part 2. Drop a comment with which single agent pattern you've used. Links to the full series playlist below.